So you have this set of formulas here. Okay, in this video, I'm gonna take these formulas or tools that you have and we'll apply them to numerous problems. Now, my assumption is that you have went over simple interest and compound interest already. If you haven't, I will do the links. So the first link you're gonna see come up now, that's on simple interest playlists, okay, on how to tackle various problems there. And the second one, you're gonna see that come up now. It's gonna be on compound interest. So please watch them, okay, before you start tackling this. Although it's not a bad idea just to tackle straight on and try to see what you can and what you can't do. Now, in anything that you do, it actually is irrelevant if you have the formulas or not, because ultimately formulas are just tools that we use to solve problems. The whole key is just because you have a tool doesn't mean that you can solve a problem. So here are a pair of tools. So you have all of these tools here. Now, can you fix something with them? Can you do plumbing? Can you wire up an electrical? Can you put up a drywall? Which tools do I use? When do I use them? And so on. And that's the thing with anything that we tackle. If you have a problem, how do we apply the actual formulas to the correct problems? And I'm going to be throwing at you numerous questions in this video. Let's do it. So here you go. So, you have 6 different questions. And I just bombarded the questions. We don't know if they're compound, if they're simple interest, what we're supposed to find. And that's the key, right? That's what you want to be able to see. So what I would recommend is if you really are doing this for a review, pause the video now and do them. Download the sheet and actually do and see what you're capable of doing, because that will really tell you how well you can apply the tools, okay, to the problems that you have. Can you wire up that electrical outlet or not? So I'm going to go through all of these, and I'm going to do it with regular calculator, and then I'll throw in the videos, okay, that are going to show you also on the business calculator, so that you have both of them, okay, side by side, depending on which one you're using. But ultimately, you have to do them, okay? You can't just watch it, right? So just watching makes you familiar with these things, but it doesn't give you any sense of being capable of actually producing the answers. Okay, so first trick in all of these questions is you have to know, are you dealing with simple interest or are you dealing with compound interest? Because clearly that tells you which formulas or which tools you're going to be applying. So let's walk through all of these, right? Okay, so question number 1, and I'm going to write them on the side here, okay, if it's compound or if it is simple interest question. So it says, how many months would you have to invest for at 12% per annum if you would like to have $12,000 from an initial investment of $1,500? So you read this and you're like, is this simple or is this compound? The biggest key is you have to see compounding somewhere in the question. Somebody has to tell you, right? Are you doing compound or not? So as I read this entire thing, I see no compounding. So this right away is a simple interest type of question. So I'll put S for simple interest here. Okay, question number 2. You have 3 debt payments, okay, of $1,000 remaining. The first payment is due in 6 months, second payment 13 months, third in 2 years. You want to pay it off, okay, with one single payment at 10 months from now. Okay, then what would that single payment be? Assume time value of money is 1.8% per annum compounded quarterly. Voila. Okay, compounded. That is the key for this whole question. This tells you right away this is a compounding question. And now you know which set of tools you're going to be needing. Okay, question 3. What nominal interest rate compounded? Again, there you go. I don't even have to read, okay, kind of further on. So it says compounded semi-monthly would you need to grow, right? 3 to 4,000 in 30 months. Another compounding question. Number 4, Jason bought a 364-day T-bill. Now, this is just experience, okay? In this case, the T-bills, okay, all T-bills within a year are always simple interest, okay? Now, even if you didn't know that, you could read the entire question and you would notice that the interests that they give you are not compounded. So this, okay, is a simple interest question. Number 5, okay, so Sabrina wants to have $1 million when she's 50 years old. Okay, so currently she is only 14 years old. If she invests at 11% per annum compounded semi-annually. There we go again, compounded. Okay, so compounded right here in the question tells us this is a compounding question. Okay, so put a C there. And the last one, okay, a $5,000 GIC is to be invested at 2.1% per annum. What is the maturity value of value after 400 days? No speaking of compounding, this is a simple interest question. So that's number 1. And this is something that you have to develop. It's like, all right, which tools am I going to be using? If you're setting up your tools in terms of formulas, you have to figure out which ones. You have to know if it's simple or compound. That's one of the first steps, okay, that you should think about. All right, so that's what I'm going to put here. Okay, so in terms of step number 1, as you are solving any questions as you're dealing with compound and interest, figure out, okay, is it compounding or is it simple interest? That's what you have to know. That's step number 1 before you do anything. Now, the second step, once you know, okay, then step number 2, what we have to do now is we have to figure out what these givens actually are. All right, so now there's a different set of givens for simple and compound interest, right? So remember, okay, for simple interest, our main kind of formula, so S is equal to P1 plus RT. So these are the things that you're looking for in the question. What is actually given here? What do they give us? Okay, and you can write them. So I always like to write these in this. The order doesn't really matter. I always say, okay, what is given? Do I know R? Do I know T? Okay, do I know P? Do I know S? Right? Which ones do they give me? Now, on occasion, they may give you interest. So if you recall, okay, so we have, okay, our interest I, okay, which is just PRT, so they may give you that. So these are the only things that you run into on the simple interest side. Now, on the compound interest side, right? So on the compound interest, so our formulas are obviously different. So we have the following formula. So this is just the future value, but this just simply tells me, all right, okay, so what I have and what I need. And now in this, okay, what I like to do is I always ask myself first, all right, how am I compounding? How many terms do I have, okay, in one particular year? Then from that, okay, I can figure out, okay, if they give me, okay, what I'm compounding at, okay, now the next thing I'll try to see is, well, can I figure out N? And now N is always the total number of terms. So that is the number of years multiplied by M, right? And you can watch the video again and again. So I'll try to link that video, okay, on the compounding factor, for example, where I go over all of these. All right. So here, okay, then after this, I have to know, okay, what is my nominal rate? Okay, and that is abbreviated as J. Okay, so what is that? And then from there, I can figure out what is my compounding term rate. Right? So these are the things that I am looking for. And then finally, do they give me the present value? Do they give me the future value? What do I have? Right? So this is step 2. Once you figure out if it's simple or compound interest, okay, then you write these things down. okay, and then you find them in the question. So let's try that, right? Let's try to knock this off. So question number 1, okay? So I'm going to take a look at this particular example. So right here, okay, and let's try to solve it. So we know that this is a simple interest question. So here are my givens. This is what I'm going to be looking for. So I'm going to be looking for these things. Okay, so I'm going to copy it down. I'm going to bring this right here. These are my givens that I want to find in the question. So those are my givens. And now I'm going to walk through the question and highlight for myself, all right, what do they give me? So they want to know how many months would you have to invest for, okay? And this is first thing, 12% per annum. Okay, so there you go, 12% as a decimal 0.12. Okay, so that's what we have there. That's my R. If you would like to have $12,000 from an initial investment, okay, of $1,500. So those two numbers, okay, is so 12,000. So I would like to have 12,000. That's my future value. My present value is $1,500, right? Now, how many months means I am looking for T? Okay, I do not know this. Now, because these two things are given, okay, I know the future value and the present value. I can figure out what my interest is, right? I know what my interest is. So my interest is always your future value minus your present value. So if you do the subtraction within here, okay, this is $10,500, okay, of interest that it has grown by. So I know I. And now, okay, if I go through this, I have to now figure out, okay, now which tool do I use, right? Now you select your tool. So step number 3, you're going to be selecting your tools. Okay, so out of these, okay, S, P, and I equations, the easiest thing is, okay, is to use this equation because I know P, and I know R. So the only one that I do not know is T, right? That's the only thing that I do not know. So right here, I am going to now use, so I is equal to P R T. Now, if you really want to know the formula for T out of this, you can rearrange this, right? And you can get T is equal to simply your interest I divided by PR, right? But you can just substitute all of these. So if you substitute these into the equation, so you will get, so 10,500, that's your I, right? Your P, your present value, is 1,500. Your R is 12%, okay? And then the only thing you do not know is T. And yes, you can substitute it in there as well, and that will give you exactly what the answer is. So if you take these, you can multiply them directly, okay? Or you can divide both sides by that. So this is T, and 10,500 divided by 1,500 multiplied by 0.12. And now if you do that, so this is not a compounding question, so we can just use our regular calculator to punch all of this in. So this is what we have divided by, I like to put those things in brackets, okay, at the denominator, 0.12, and this does it all for us. So T here in this particular case, okay, is 58.3, okay, bar, because it's 3333333. All right, so this is what we have. Now, the crazy part is this is years, right? This is all years. So for this example, how many months would you have to invest for at 12% to make it grow that large? Okay, simple interest is just not going to cut it, right? Because if you want this in months, well, that's how many years, and this is how many months you have. So the reality is that this you would have to still multiply by 12, and that is 700 months. Okay, so 700 months that you would have to do that. And those are the little things. You don't get that from a tool, right? You have to get a sense and understanding of how do you tackle these particular examples. So that is question number one. Let's take a look at question number two. So you have now three debt payments. So we have three debt payments. We already know this is compounding. So again, don't forget. So we have three debt payments. Okay. The first payment 6 months from now, second payment 13 months, third payment in 2 years. So when you are doing all your givens, this isn't just a regular type of question. And again, this is what I mean. It's not just having tools for this. You actually have to know and understand how these questions are set up. So for this example, okay, so what we have, this is an example where we are dealing with equivalent values in the time value of money because we have multiple payments in some way. And I see this and I know, I can already see, okay, what do I need? I need to see this visually. Okay, so what's happening? Because this is not just one payment. You can't just go ahead and just use it for one. There's three things happening. So there's a first payment, okay, 6 months from now. So let's say if this is now, this is 6 months, and so this payment is $1,000. There's a second payment due in 13 months. Okay, so let's say this is now 13 months, and that would be your second payment, okay, of $1,000. And then there's a third payment due in 2 years, right? So 2 years is 24 months. I'm going to put it far off in here, so 2 years or 24 months, and that is my third payment. So these are these odd payments that we have. Now, if you want to pay off the debt in a single payment in 10 months, so we want to pay this off in one single payment, so 10 months, let's say it's somewhere right here, right? This is basically your focal date. That's what we want to focus in the money in, because we can't just arbitrarily take the 3,000 and say, well, we're going to be paying off 3,000 when there is an actual time value of money at 1.8% compounded quarterly. So if that's what it is, then what really we're going to be doing is we're going to be bringing all of this money back into that focal date. So we're going to be doing this. That's what we're going to have to do, because we can only compare it the same day, okay, when it is interest related. So now I do know that it is 1.8%, okay, and it is quarterly. So that I do know. So in terms of my givens, okay, at least for this particular question, so what I have, it is compounded, right? So first figure out M. So it's compounded quarterly. So M is 4, because we have 4 terms per year. Then now N is going to be different for every single one of them. So if you move this, M is different. If you move this, N is different. Okay, and if you move this, N is different. So I can't just write N because there's not one single N, because they're moving different amounts of time. Now our J for this example is 1.8% quarterly. So that's what we have. So 0.018, okay, and your I would mean it is 0.018 divided by 4. So that's my I. That will be the same for all. All right, so now let's knock them off. Okay, and this is something that we have to think about because we're moving money back and forth. So number one, okay, so for number one, what we want to know is, well, we know M, we know J, we know I, we want to know N. Okay, we're compounding quarterly. N is the number of years multiplied by M. So I am moving from 6 months to 10 months. So that is only 4 months. Now, 4 months, so 4 divided by 12, that gives me the number of years multiplied by quarterly. Okay, so that is 4, which is M. So this right here, so this is 16 over 12, or simply just 4 over 3. And I'm going to keep it that way because if you put it in as a decimal, you're going to get 1.33333333. Don't round it. So I'm going to keep it as, okay, an actual fraction. And now what else do they give me? I am moving money forward. Okay, I am going from here to there. I am going in this direction. I am moving it forward. So that is my present value, okay, which is $1,000. And since I am moving it forward, I need to know what the future value is. And my future value is present value, 1 plus I. So I is 0.018 over 4, okay, to the power of n, and that is 4 over 3. So how do we input this in, right? So here we go. Let's put it all in. So I have 1,000 times, so open my bracket, 1 plus 0.018 divided by 4, close bracket, to the exponent. Okay, and now I'm going to open the bracket in the exponent because it's a fraction. So 4 divided by 3, close it. Okay, hit equals. So that's what I have there. So this gives me, okay, what my future value is. And it's not big, 100, because the interest rate is very small. Okay, and I'm going to round it to the penny. Okay, so notice that's what it would be. I'm going to just keep it that way. So that's number one. Okay, so this is what you would have there. That's this one. Now let's move number two. So now if you're moving number two, notice it's going from 13 months to 10 months. Okay, so from 13 months to 10 months. So for number two, what you have, so n equals, so from 13 to 10, that's 3 months. So 3 divided by 12 times m. Okay, so that's what this equals. So now, if you do that, so that's going to be just 1, right? 3 times 4 is 12. 12 divided by 12 is 1. And now, in this case, we're moving money from 13 to 10. So we're going back in time, right? So we're going back in time. So now we know what the future value is. That's supposed to be 1,000, and we want to find out the present value. So present value is, okay, so future value, if you go to your formulas, 1 plus I, so 0.018 divided by 4. Now it's, don't forget, to the negative, and in this case to the negative 1. So if you do that, so what we have is 1,000 times, okay, I'll open bracket, 1 plus 0.018 divided by 4, close the bracket, to the exponent. Now don't forget it's negative, okay, in this case it's just negative 1. So it equals, and it should be less because you're bringing money back. So again, I'm going to round it to the penny. So this is what we have. That's for number two. Okay, so that's this one right there. Now, number three. Okay, so this. Again, I'm moving money back, but now I'm going from 24 months to 10 months. That's 14 months that I am moving. So my last one that I have here, so number three, so my n equals, again, from 24 to 10. So that's 14 months I'm going back. divided by 12 because this is supposed to be number of years, multiplied by m, which is 4. All right, so now if you do that, okay, I'm going to reduce the fraction here. Okay, so it's 14 times 4 and then over 12. And then you can reduce the fraction. But I noticed that 4 actually goes into 12 3 times. So this is just 14 over 3. And I just keep it. Okay, I just leave these as fractions. I don't change them into decimals. I'll let the calculator do that for me. And now again, I am moving back in time. So I do have the future value, which is 1,000. Okay, so now that's 1,000, and now I have to know my present value, so PV. So 1,001 plus I, so 0.018 divided by 4, and it's again negative 14 over 3. So let's put it in. So I have 1,000 times 1 plus 0.018 divided by 4 to the exponent. Don't forget your negative. Okay, now I'm going to put it in brackets. So 14 divided by 3. Hit equals. And it should again be less. Now, depending on your calculator, if you're using scientific one, okay, you have to be careful on how you input these in. So now I have all of these. Now, I was supposed to have just one single payment, right? That's what I wanted to have. So what do I do with all of these? I have 3 of them. So I have this one. If I moved it to 10 months, that's the equivalent value of the $1,000 from 6 months. I have this one. That's from the 13 months. And then I have this one. So if I want a single payment, I have to add these up. And then that's going to give me my single payment. So my single payment that I would have is, so I can add all of these up. So if you would add them up, so I have, okay, so 9, so 79.27 plus, okay, 995.52 plus 1006 equals. That would be your single payment, 2980.79. That's your single payment that you have. And yeah, it's a lot of work, right, that you actually have to go through this. And again, it doesn't really matter if you have those formulas in front of you or not, because this takes effort. You have to see these questions. You have to conceptualize and understand, and comprehend equivalent values, okay, for this concept. Okay, so that was example number 2. So we've knocked out 2 of them. Let's take a look at example number 3. So notice it's compounding again. So here is my example number 3. I'm going to copy that down. So what do we have there? So it says, what nominal interest rate, compounded semi-monthly, would you need to grow this from 3 to 4,000 in 30 months? So this one's a lot simpler, okay, than the other one. So for this one, as there's only one thing to deal with, so we're going to write down the givens. So given, okay, so what are we dealing with? And because it is compounded, so notice, we start M. How are we compounding? Semi-monthly. So semi-monthly means twice per month. So this becomes 24. N, okay, it says 30 months in total, right? So again, so 30 divided by 12, that's going to give me the number of years times that. Now notice 12 goes into 24 2 times. Okay, so this becomes 60, and that should make sense because it is twice per month. So 30 months twice per month is 60. Now, my nominal interest rate, J, we do not know. okay, which means I also do not know I, right? I do not know these. But I do know my present value, which is 3,000, and I do know my future value, which is 4,000. Okay, so now these are the two things that I do not know. And this is the other component of, picking off the tools. So we know this is a compounding question. So if I go back, so I know it's a compounding question. And now what am I solving for? So here, well, I have the future value, I have the present value, I know n, but I don't know I. So that's the formula that I would have to use, right? This is what we would have to use in order to make this work. So that's what I'm going to choose. All right, so this is the formula. Let's find out I. So if I go back to the question, so we have, and let's write down the formula. So it is I is equal to, okay, so it's future value divided by present value, 1, okay, over n minus 1. So that's what I have to now solve. And I can just plug all of this in, right, and try to see, okay, what happens here. So I have future value, which is 4,000 divided by 3,000, 1 over, so this is 60, so that's n right here, minus 1. And now I have to punch this into the calculator. Now, if you had your business calculator, you can use that as well. All right, and I will do a video on that one and link it right after, okay, and add it to this. So let's do that. So open bracket, so 4,000 divided by 3,000, close bracket. Now to the exponent, okay, and it's a fraction, so I always put it in brackets, so 1 divided by 60, close bracket, minus, okay, 1, hit equals, right? Now, remember, this is I as a decimal. So this is 0.0048062 and so on, right? That's as a decimal. Now, they're asking us for the nominal rate. So we have to take this because this is I. We want to know J. But the J, okay, is nothing else but I multiplied by M. And that comes from the fact that we have this, right? So if you rearrange this formula for J, it is just that. So I'm going to take this, okay, and then multiply it by, so I'm going to multiply my answer by 24. And now if you want to change it and make it a percent, you of course can multiply it by 100 and you will get, so 11.5%. Okay, that was our nominal rate, compounded semi-monthly. Okay, now let's try to do this one by a business calculator. So we have M, we know N, right? We know our present value and future value. Okay, so now in this particular case, notice this, it grows from 3,000 to 4,000. So we're gonna have to be careful how we input these. Okay, so one of them is gonna have to be negative when you're inputting it into your business calculator. So instead of using this formula, we wanna see if we can get this 11.5% for nominal rate, okay, by the business calculator. All right, so notice, okay, so what I have here is, okay, so my business calculator, so let me just second function, okay, clear TVM. All right, now let's enter all the data in, okay, so second function this, okay, so we do need 24, okay, enter, because it's semi-monthly, so that's my M, okay, so how many times we are compounding per year, okay, so that's 24. Now my N is 60. So let me write 60n. I don't know my nominal rate, so I can't input it in. I know my present value. So present value is 3,000. I'm going to keep it negative, right? One of them, future present value, one of them has to be negative, the other one positive. So money coming out means we're investing it. So that's my present value. My future value, okay, so that's 4,000. Then you hit future value. And I'm just going to hit compute. And now I can find out what I is. And notice it's 11.53 and so on, which is exactly what we got in our question. Okay, right there. All right, so let's tackle question 4 now. So we said that this was a simple interest question, and indeed it's true that T-bills, so treasury bills, okay, so within the 1 year, okay, so they are purchased at discounted yields. And you have to do these questions in order to be able to understand the process. Okay, so we bought a 100,000 364-day T-bill 100 days before maturity, okay, to yield. What I like to do with these types of questions, now, if this was all that was asked, right? Let's say we only had this T-bill, it was purchased 100 days before, and the yield is 1.05% per annum, right? So let's imagine we have that. So what does that actually mean? Now, because I like to write the givens, every so often I like to visualize them just so that I can see. So now with T-bills, I do recommend, okay, so let's say that we want to be able to visualize this. And you can imagine, right, so that you have purchased this T-bill, or at least somebody purchased it originally 364 days, right? That's the T-bill, and it's a 100,000 T-bill. And again, remember that this 100,000 that we have, that is always the future value, right? Because you buy T-bills at yields. So what this is saying is that we have this 100K sitting there at the end that we would get it back. And we buy them at basically discounted yields or rates. Now, for us, we have bought this T-bill 100 days before its maturity. So we didn't buy it 364 days. We bought it basically 100 days before, right? So this right here, so from here to there, that's 100 days. So that's when we bought it. Now, it doesn't tell us how much we bought it for, but it does tell us what the yield is. So we can certainly try to figure out, okay, what did we buy this thing for? So what we have to do is we'll take the 100,000 and we're going to be bringing it back 100 days, okay, at a yield of 1.05% per annum, and it's simple interest. So let me do that first just so that we can get a gauge on how much we actually bought this thing for. So the rate, okay, so it's not very much, 0.0105. The time T, so it's 100 days, okay, before it is due, and that's over 365. And as we said, okay, so we know the future value or the maturity value of this thing, and that's 100,000. Now, if I want to know how much I bought it for, so that's P, and sorry, because it's simple interest, I'll just keep the future value as S, or which is known as the summation value. So now my P, my present value or principal, okay, at the beginning of that purchase, okay, is or can be calculated by simply, okay, S divided by 1 plus RT. All right, so this is what I have, and I can punch all of this in. So let me put 100,000, okay, divided by, and 1 plus my rate, okay, times 100 over 365. So that's what I would have to do. Okay, and now let me punch this in just so that you can see it. So I like to, okay, we'll do this. So that's 100,000 divided by, and then I put the whole thing in brackets because I'm dividing by the whole denominator. So 1 plus 0.0105 multiplied by 100 divided by 365. All right. So that's the whole thing there. And it should be less, right? Because we are purchasing it at a discount. And I'm going to round it to the penny. So this right there tells us how much we purchased it for. So that's that first sentence. It just tells me, okay, that's what I bought it, right? Now, if the T-bill was sold 40 days after it was bought, okay, so if I zoom in here, so it was sold 40 days, okay, so after it was bought, which means there are still 60 days remaining. And this is the trick, okay, because it's sold at a 0.89% per annum. Okay, so how much did we sell it for? So that's the second question, right? Now, how do we do that? Let me get rid of some of these just so that I get rid of the clutter. Okay, so that's that. So how do I do that? Well, with T-bills, remember the future value never changes. So it's not like you can start with this right here, okay, and then just move it over. No, with T-bills, okay, this maturity value always stays the same, and that's what you always use, and then you find out, okay, what is the yield? Now, the yield for us in this second instance is 0.89, so it's very tiny. That's what it is, and it's 60 days before. So for my second, so my rate now, okay, is that. Again, remember, we divide by 100 to change it to decimal. My T is 60 days to maturity. So that's how you always work with T-bills, always compared towards maturity. And again, if your future value doesn't change, because it's not like the T-bill face value will change. So that's what we have there. And now again, I play the same game. I basically will take 100,000 divided by, so now my rate has changed, which is 0.0089, okay, multiplied by 60 over 365. So if I punch this in, so again, 1, 2, 3, divided by, open bracket, 1 plus, okay, 0.0089 multiplied by 60, okay, divided by 365. All right, so all of that was in brackets, and I get 99853.91. That's how much I sold it for, right? So this is how much I purchased it for, and this is how much I sold it for. So if I want to know how much I made on this sale, well, then hopefully you can see that, well, this is our selling price minus our purchase price. And it looks like I will make, I mean, not, it won't be a lot, but I will make a little bit. And I just punch that in. So 99853.91 minus 99713.15 equals. So I basically made $140.76. That's how much I made. So the biggest key for all of these T-bills that you run into, remember that your face value, your maturity value never changes, and you always compare it to that. So it doesn't matter what's happening, you have to know the yield, you have to know the maturity face value, and then you just simply shift, and you're always basically just calculating your principal or your present value to find out. Okay, so that's how you would tackle this particular question. So for this question number 5, we know that it is compounded already. All right, so we have that. Now, we want to have $1 million, okay, at 50 years old, and we're currently 14. Okay, so now, what does the initial amount need to be? So for this example, you can go right in, so it's compounding, so M We're compounding semi-annually, so that is twice per year. Our n, okay, so notice we need to know how many years multiplied by m. Now, we're going from 14 to 50. So if you subtract that, that is 36 years multiplied by 2. Now, my j, my nominal rate, is 11%, which means my I is 0.11 divided by compounded semi-annually, so that's that. Now, I know my future value, so my future value, okay, is 1 million, and I do not know my present value. So this example, out of our toolbox, we need to use our present value formula, which is our future value. Okay, 1 plus, okay, so I, which is 0.11 divided by 2. And because we're working with future value, don't forget, so it's negative, okay, and our n, so 36 times 2 is 72 in this case. And now we can find out how much that would be. So if I do that, so multiplied by 1 plus 0.11 divided by 2 to the exponent, and again, so it's negative exponent. So that would be 21,174, and I'll round it to the penny. So we need approximately, so interestingly, okay, we need approximately 21,000, right? So 21,174.98. That's how much we would need, and it would grow if we're lucky enough to be compounding at 11% semi-annually. Now, how would we tackle this same question if we wanted to do it with just a business calculator? So I just want to quickly show you, and if you're not interested, of course you can skip, but I do highly recommend it. Now, once we have our M, we have our N, we know what our nominal rate is, okay, and so on, future values, we can input all of these. So instead of, using a regular calculator, we can just input this back in, okay, into business calculator. So let me show you, okay, so how that can be done. Now, so here it is, okay. Now, the first item that we need to do is, so I'm just going to clear this thing. So second function, so clear TVM, time value of money. And now I'm going to have to just enter all the things that I want. So my M, okay, so here, okay, so second function, that, so it is already at 2 because we're compounding twice per year. Okay, so I'm going to keep it that way. I'm going to exit, so second function quit. So let me now go back and fill all of these. So what was my N? Well, so N was 72, so 72, that's N, right? My I, so my interest, in this case you put the nominal interest, so that was 11%, so that's my I, and then my future value, so that's supposed to be 1 million. Okay, and I'm going to hit just future value right here. So now the only thing that's missing is the present value. So I'm going to hit compute, okay, and I'm going to hit present value, and it gives me. Now notice it is negative, okay, because in the business calculator world, okay, so there's always inputs and outputs. So because our future value was an input, we were receiving that 1 million. That means we had to actually put out or invest this amount. And notice it's exactly the same. So 21,174, okay, 98. So if you, if I go back here, that is exactly what we have right there. So that's how you would tackle that with that business calculator, in case you wanted to know. Okay, so this last one, and this one is 5,000 GIC, and it's invested at 2.1 per annum. What is the maturity value after 400 days? So we know it's simple interest. There's no compounding. So this one is actually much simpler than some of the other ones. But that's why I just gave them to you in random, right? Because that's what happens. You kind of randomly approach these things in life. It's not like, here you go, here's a set of questions and they continuously repeat. we have to be able to apply our tools of simple and compound interest to these. Okay, so simple interest, I need to know R. This one is given. I need to know T. In this case, it's 400 days. So don't forget, okay, so it is in years that we want it. So we always divide by 365. Now, I also have, okay, the present value, so or the principal P, which is $5,000. So all I'm looking for is my future value in this case, and that is, much simpler now. So I can plug all of this in. So 5,001 plus, so 0.021 multiplied by 400 over 365. And now we can just punch this into our calculator, so we can do that. So let me kind of shift this over. So 5,000 times, okay, open bracket, 1 plus, and 0.021 times 400 divided by 365 equals. All right, and this would be our answer, and round it to the penny. That's our future value for this example. And that wraps it up